we try to measure the chance of a particular outcome. So our basic objective is to evaluate the chance of a particular outcome, or a particular type of outcome, or a particular, sorry, of outcomes of a random experiment. That is our basic objective of probability theory. Now, the problem is how we do this. This evaluation, we have several evaluation methods in probability theory, and today I will start with a very simple definition of probability. It's a simplest method to calculate probability, and we call it classical probability. So what is the classical probability? Suppose I want to, suppose I want to measure the chance, or I want to find the probability of an event of at least 2 heads while I am tossing the coin thrice. Okay, let me write it. Suppose, okay, first I will write the random experiment, because if the experiment is not random, then outcomes are certain. Random experiment না থাকলে outcome গুলো uncertain হবে না, তাহলে চান্স মেজারের কোনো প্রশ্ন আসছে না। Suppose we are doing the random experiment, tossing a coin thrice. Tossing a coin thrice. And we want to know the probability or we may call it we want to know the manifestation or evaluation, whatever be. Manifestation is a more technical term of the chance. Manifestation of the chance and probability both are same thing, I mean, not different thing. So we want to know the probability of, I'm putting this inside a bracket. We want to know the probability of getting at least 2 heads. Okay. Now, when we go by the classical definition of probability, first we have to write down the sample space. While we are tossing the coin thrice, our sample space will be like this: HHH, HHT, HTH, THH, TTH, THT, HTT, and TTT. And we are looking for the event or events where we have at least 2 heads. Then basically inside of this sample space we have a favorable zone, or a zone where we are interested. I am marking with the favorable events with red. If HHH or three heads happens, then we have at least two heads inside of three heads. So HHH is our favorable event. HHT, this is also our favorable event. HTH, here also two heads. And again THH, this is also. Now TTH, if we get TTH, is this our favorable event? Because in TTH, we have only one head. But we are looking for at least two heads. So TTH is not our favorable event, right? Now, classical definition says if the sample space is finite, okay? If the sample space is finite and all the members inside the sample space are equally likely to occur. আমি এটা বাংলাতেও একবার বলছি, স্যাম্পল স্পেসটা যদি ফাইনাইট হয়, finite means you have a countable sample space and it is not countably infinite. Finite মানে হচ্ছে তুমি গুনতে পারবে and তুমি গুনে শেষ করতে পারবে. This sample space is definitely finite because we have only 8 members inside this sample space. এই sample space এর ভেতরে 8 জন মেম্বার আছে, এটা অবশ্যই ফাইনাইট. Classical definition বলছে if the set is finite, sample space is finite and all the members inside the sample space are equally likely to occur. So let me write this, okay? According to classical definition, I am writing it because this definition has a serious problem. According to classical definition of probability, if the sample space is finite, which means cardinality of sample space or the total number of members inside the sample space is a positive integer. Positive integer. And it has a second condition. Classical definition is a second condition. First condition, sample space is finite, and the second condition is all the members inside of the sample space is are equally likely to occur. Then probability of any particular type of event A, PA, equals to number of elements inside the sample space in favor of A divided by total number of members inside the sample space. Okay? For the sake of simplicity, just assume in our experiment we got this sample space and all the members inside this particular sample space are equally likely to occur. Just assume it for the sake of simplicity. Then the event we are interested in which is getting at least two heads. This is basically the set A, and the members of set A are this one, this one, this one, and this one. So basically, we got a set A with our favorable events, and the set is a subset of sample space, and it will be like this. Right? Now, how many members do we have inside A? We have 4 members. And how many members we have inside S? We have 8 members. Our answer will be half by the definition of classical definition of probability.